So welcome to our opening plenary on planetary protection. So I'm Ariel Anbar, and on behalf of myself and Louise Proctor, my partner in crime in organizing this session, I want to welcome you to Greater Phoenix, Arizona. And it's really exciting as somebody who lives here and works here. It's really exciting to see you all here. So we're going to try to do something a little different this morning. When you hear the words planetary protection, you don't normally think of fun and entertaining and engaging, but we're going to try to do something that is fun and entertaining and engaging and a little experimental. So we'll see if this goes well, but we think it's going to go pretty well. Why are we doing this? So planetary protection, it's never been more important to consider, because of missions to Europa and maybe Enceladus, hopefully Enceladus, and ever more serious planning for Mars sample return, because of the rise of private players like SpaceX who want to go to other worlds, and because of ever increasing public interest in life on other worlds, planetary protection is something we're going to have to deal with more and more as we move forward. As we talk about planetary protection, it's really easy to get lost in debates over technical requirements and history and policy, and sometimes cost comes up as an issue too. There's going to be plenty of opportunity to go into those kind of topics in the planetary protection sessions that happen later today. But this morning we want to sort of take a step back from all those weeds, from all that detail. It's all important, but we want to take a step back from all that to stimulate a community conversation that we hope will live on beyond this session and beyond this week, and maybe get people thinking a little differently about the topic, about why planetary protection matters in the first place, why it's an issue that we all need to take seriously, and to get us all thinking about why there's such diversity of opinion about it, because that's really the source of a lot of the tension. Tension is a reflection of so much diversity of opinion. So to do that, instead of giving you a history lesson or a detailed lesson in planetary protection policy or something like that, we instead turn to someone who regularly deals with controversial issues like this, issues that are on one level technical and regulatory, but that underneath that surface are really about differences in values and differences in perception of risk, and how that then translates into policy and action. And so I'm pleased to introduce Andrew Maynard. Andrew is not an astrobiologist. He's a professor in ASU's School for the Future of Innovation and Society, trained as a physicist at University of Cambridge, but now running the Risk Innovation Laboratory at ASU. So he's a professional at dealing with these sorts of challenging technical, values-laden issues. And he's going to lead us through a fun, interactive, and participatory session. So Andrew.
Great. Thank you very much. Well, thank you. Thank you for turning out just past 8:30 in the morning for what Ariel said is an experimental session here. So actually, let me just put up the first slide. So you probably or hopefully got the email last night saying, come prepared to interact with your phone, with your computer, with your tablet. Many of you probably also realize that ASU has got a problem with its email system in that what should have been a really short URL ended up being about 200 characters long and probably didn't work. We'll get to that in a minute. But this is going to be highly interactive. And it's going to be a session where I hope I can get you thinking in slightly different ways about some of the challenges and opportunities around planetary protection. We're not here to find solutions, but we're here to start thinking differently. And just to add to Ariel's introduction, so why am I standing here? Well, one reason I think I'm standing here is that if I make a real mess of this, I can run away and Ariel can say it's not my fault. So I'm the fall guy here. But I'm also somebody that has worked across many different domains. I worked for many years as a physicist, a lab scientist, working with aerosol dynamics, but I've also worked on the policy side and science communication side around risk and decision making, especially in areas where there's huge uncertainty. And that's the perspective that I want to bring today, to try and get you thinking, as I said, slightly differently about planetary protection and how we can possibly move forward to achieve what are largely common goals in a very complex area. Okay, so to start with, I said if you have a phone or a laptop or a computer, now's the time to take it out, because the first bit here is going to be getting you used to exactly how we're going to run this. We're going to be doing some real-time polling here. And the first few polls are just to get you used to the idea before we get to the serious stuff. Okay, so you can join using text messaging, SMS, or you can join the web page. Let me just show you what this looks like. So if you want to get onto the website, instead of that 200+ character long web URL, it's simply polev.com/abscicon. If you go to that page, it works well on your phones as well as on laptops. You should come up with a page that says, this poll hasn't started yet. But you'll actually be in a session where you can begin to interact. If you want to join otherwise by text, this actually works really nicely, but you've got to join the session. So you need to text abscicon to this number, 37607. As soon as you've done that, actually it'll take a few seconds. You should get a message back saying you've joined the session. And then once you're there, every time there's a question on the screen, you can just text your reply or your answer to that question. You'll get the hang of this fairly quickly. OK, so we're just going to try this out to make sure that you're actually awake. And there we go. Oh, wow, people have already started coming in with this. OK, so this is the first simple question. OK, where do you call home? And I love the fact that immediately you can see who this crowd is, because Earth is there right in the center. Where else is really interesting? So either some people can't spell, or there are some really interesting places here. There's milk. Oh, yeah, so I should say, and this is one of the reasons why we do this. So one-word answers only, so you can see a milky there, and then presumably there's a way somewhere else in there. So if you really do want to put phrases in, make sure you put dashes or something in between, otherwise all the words will be separated out. OK, good. So, OK, interesting that California comes a sort of close second behind Earth. I'm not quite sure what that tells us. OK, good. So you get the idea. I'm going to move on from here on to the next one. OK, next question. Actually, just a minute. Let me go. Yep, that is the next one. OK. So let's try this. How long till Elon Musk establishes Muskville on Mars? Let's see how quickly the over my dead body comes up here. Actually, it's surprising the consensus, 20 years. I'll give you a second longer there. So I'm glad to see very few people think it's going to be in the next 10 years, although I think Elon Musk would like to think that maybe that's a possibility. OK, but interesting that this is something that seems to be a plausible future reality, that within the next 20 years, maybe a little bit longer, we're going to see a private enterprise establishing some sort of base on Mars. OK, next one. OK, getting a little bit more relevant to this conference. What's the likelihood we'll discover non-Earth life in the solar system? There's a few yeahs there. There's a few zeros as well. Interesting. So the beauty of this, and I should have said this is anonymous, so you can actually express your real self here rather than the self you feared you have to express to your neighbors and get away with it. But yes, not surprisingly, most of you think that this is a possibility. I'm interested in the zeros or unlikelies here. Yeah, that's a conversation for coffee, I think. OK, moving on. What words capture the purpose and goal of space exploration? Again, one-word answers, or if you do have to have a phrase, put dashes or something there. Here we go. Curiosity, knowledge, discovery. Great. Longevity, wonder. I love this because it really gives a beautiful snapshot of how people are thinking positively and in an excited way about what the possibilities and what the purpose is here. Not surprisingly, curiosity and discovery there up front. Knowledge, philosophy, cures is a really interesting one. Aliens, adventure, life, E.T. I like E.T. And just give you a second with that, because this really begins to sort of capture how you're thinking and where your aspirations and your goals are here. Survival is an interesting one as well, actually. And I love that we've got a French curiosity as well in there. OK. OK, that's great. I'm going to move on to the next one. OK, now getting into risk. So going from excitement to something a little more dour. What comes to mind when you think... I knew I could rely on this audience. Danger, Trump, death. And it's not going away. I'll give you a second longer. Just in case anybody wants to get rid of the Trump, I don't think you will. It's still, oh, well, there's fun there as well. It's gone now. There was a little bit of fun right in the middle of Trump there. Failure, reward, uncertainty, opportunity. Yeah, so actually, slightly more serious. You've got all the downsides of risk here, but then you've got a few things like opportunity in there. Necessary. What else? Got some bad things, yeah. But there are one or two things there which aren't necessarily negative, and this is going to be really important as we start thinking slightly differently about risk. Risk isn't always about the bad, but it's about how you actually get to where you want to be. But still, danger, Trump, death are in the center. Okay, and more serious still, what comes to mind when you think of planetary protection? Management cost. And this is where it's really important that this is anonymous. Contamination, yes, as you would expect. Musk is there, tedious, difficult, controversial, problem, overboard, wisdom, non-contamination, yes, sustainability, preemptive strike. See, Cassie is up there. I'll give you a second longer on that. But this is safety and contamination. So this is really helpful to me because it gives me a sense of where the room's thinking is when you begin to think instinctively about planetary protection and how you feel about it. And very clear here, there are these fears or these concerns or this thinking around contamination and safety. And then some of the other things that come in, like the word overboard, for instance. I think from what I understand of this area and the communities, there are different ways of thinking about this. And this is what makes it such an interesting, complex, sometimes controversial area. But nevertheless, very, very important, as that big word contamination says. Okay, this is great. So obviously, the system is working. At least it's working for at least 250 of you, which I think is good enough. So let's move on into a little bit of the meat of this. So that was a great start. It made sure that you understand how the system works. It's given me a sense of where your thinking is. It's given you a sense of where your colleagues' thinking is on some of these issues. What I want to do now is I want to begin to work out how we can frame planetary protection in a way that actually opens up conversations and helps different communities work together to try and understand how to crack what is a really complex nut so that we can do what we set out to do when it comes to space exploration. But to do that, I thought I would start off by giving you what I've called it a naive perspective on planetary protection here. I should say, if you haven't worked out, I'm a Brit. And as a Brit, when I use words like naive, I actually don't really mean I'm naive. It's just the way that we self-deprecate. So I'm not quite as naive as I might make out. On the other hand, if you think I'm speaking absolute rubbish, at least I can fall back and say I was just naive. But let me at least explain to you what I think about when I think about planetary protection. So this, to me, is what the nature of the challenge is. We're sitting here on Earth, and we're sitting in a solar system with all sorts of other entities. And we have lots of biological stuff on Earth that we're worried about taking out into the solar system, but we're also worried about the possibility of biological stuff being in the solar system and even beyond that we might bring back to Earth. So this, to me, is at the heart of discussions around planetary protection. Why is this important? Well, many reasons, but some of the big ones are obviously, and you saw from the word cloud, contamination. We don't want to take stuff out from Earth out into the solar system and contaminate other systems. We've also got the problem of confounded science. If we're trying to do science on non-human or non-Earth life, we really don't want to take our stuff out there and completely mess the whole enterprise up. But obviously, coming back the other way as well, there are concerns about environmental harm if we bring biological stuff that did not originate on Earth back here, but also the possibility of human harm as well, and still that idea of confounded science. That if we have contamination in the system, whether we're going out or whether we're coming back, it really messes up our ability to do good science. So this is the framework that certainly I think about when I think about planetary protection. But there are a lot of other contexts here which are important. One of the contexts is, why do we explore space in the first place? Why are we trying to get out there? Why are we trying to do stuff? And of course, there are many reasons why we do that. There's discovery, there's new science, there's learning about ourselves and our place in the solar system, the galaxy, the universe. There's exploration as part of that. There's fame. There are one or two people that would like to make their names by going out there. I'm not going to name anybody here. There are economics. Believe it or not, some people think that maybe one day there's going to be an economical advantage and profit from space exploration. But then there are other things which make things even more complex. There are the ethics of what we do. The ethics not only of even should we go out to other bodies in the solar system, but how we work out what is appropriate and what is not. There are values associated with that, the things that we individually and as different groups consider important here. And that leads to ideologies, the things that drive what we think is right and what we think is wrong. And these aren't necessarily right or wrong, but they're different between different people, different communities, different organizations. And then, of course, there's policy. There's what we've decided as communities, as countries, as a society as a whole, in terms of what is appropriate and what is not, and what the guidelines are for how we do the right things. And of course, wherever you've got policy, you've got politics. Perhaps not surprising, Trump came up, and actually it's quite a good thing that Trump came up, because there's always politics involved with these messy decisions that involve people and profit and everything else which is not just pure science. And then, of course, there's a massive amount of uncertainty. From a risk perspective, we really are in a space at the moment where we're grappling with things that we really have no idea what lies in the future, and we have very few ways of actually working out what we're likely to find and how we're likely to build resilience into our system, so if we find something new, we can manage it. And of course, all that comes down to risk. So in my head, when I think of planetary protection, I think of this really complex, messy landscape, which is summed up by simply saying it's wickedly complex. There are no silver bullets here. There are no easy solutions to moving forward to an approach to planetary protection that works and everybody is happy with. And in fact, in the social and policy sciences, this is what we call a wicked problem. Some of you may be familiar with this term, others not so. It's typically not a problem that's used in science and engineering, or a term that's used in science and engineering. But a wicked problem is a problem without clearly defined solutions. In fact, worse than that, a wicked problem is the sort of problem where as you try and develop and implement solutions, the nature of the problem changes. So you're always chasing after a moving target. This makes wicked problems incredibly difficult, but it doesn't mean that we don't address them. It just means we need to be quite smart and sophisticated in how we begin to develop solutions and how we begin to change tack as the nature of the problem changes. So this is part and parcel of one of the areas that I work in, which is called risk innovation. And I want to just spend a few minutes talking about what this is, because I think it'll help frame the following discussion. So risk innovation is, in fact, actually, before I tell you what risk innovation is, let me just ask this question, because I can riff off this. Is this, yeah, we are. It's going to kick in. So when I mention the word innovation, just put up what first comes to mind in terms of words here. New, novel, exciting, scam, I like that. Especially as you're being hosted by what is supposed to be the #1 university for innovation in the country. Creativity. Yeah, there was a delay with that slightly embarrassed chuckle there. Corporatism, exciting, opportunity, knowledge, unusual. ASU #1 in, thank you. That's buzzword, cool, yes, leap. What else do we have? Implementation, Musk again. Musk appears on all of these. Okay, great. So a lot of positive words there about innovation, but this idea of creativity and new is there as well. So the reason I ask this, and to lead into this idea of risk innovation, is when it comes to risk, we tend not to be creative. We tend not to think in new ways. In fact, most of the thinking about risk assessment, risk analysis, risk management, no matter what field you look at, is very, very conservative. And most of this has worked well in a world which has been largely predictive. We've been able to sort of work out how we come up with models for assessing risk in a world which is largely invariant. These approaches to risk do not work in a world where things are changing rapidly and very uncertain. So one of the things that we set out to do in my center, the Risk Innovation Lab, is to ask, how can we bring the mindset of the innovator, the entrepreneur, to thinking about risk? How can we bring creativity into the process of thinking about risk and see whether we can approach risk in new ways which actually help us find solutions to complex, wicked problems? And I'm not going to say too much about the actual work we're doing there, but I am going to talk about 3 things that come out of this sort of thinking about risk. They're 3 very, very simple things, but the first thing is this idea of thinking about risk as a medium to be traveled through. Not thinking about risk as something that's bad to be removed or something that has to be managed, but thinking of risk that's something that's necessary. So effectively, something like this. You're here at the moment, you want to be somewhere else. The only way you can get to where you want to be is to move through this medium of risk. This is simple, it's obvious, but it's not how we usually think about risk, because this says that there's always going to be risk in everything we do. In fact, one of the things I tell my students is the only way to get rid of risk altogether is to be dead. And it's not a particularly good solution to any problem. So somehow we've got to get into the mindset where we actually think about moving through this sea of risk and trying to work out which risks are the ones that we want to grapple with, how are we going to trade off those risks against the benefits that we're going to receive. What we cannot afford to do is try and get rid of risk altogether. So the second thing that comes out of this way of thinking is this idea of risk as being a threat to things of importance, to people, to groups, and to organizations. So we usually think about risk as something that'll maybe harm the environment or harm individual people or communities, possibly cause death. Those or possibly lead to financial ruin. So those are the 3 big areas we tend to think of risk in. But risk goes way beyond that. So risk can even come down to culture, personality, deeply held beliefs, your sense of yourself, your sense of identity. These are things that deeply motivate us as individuals and as humans. And if we don't incorporate them into our thinking of risk, we miss something really important. So this idea of risk really expands from the individual, thinking of what is it that is going to threaten somebody, whether it's going to threaten their health, their beliefs, their sense of purpose and their identity, to beyond that. What is it that's going to threaten groups, especially groups that have got deeply held ideas about what is right and what is wrong? What is going to threaten institutions? Again, institutions that may have vested interests in doing things in a certain way. All of these are different aspects of risk. And going back to that previous slide, thinking about moving through a sea of risk, you can't understand the nature of that sea unless you begin to understand what is important to these different groups, from individuals to organizations, what they're going to fight for, and how you navigate around that. And then the third thing which leads on to this is the idea of risk as a complex landscape to be moved through to reach common goals. So this begins to tie in with those first 2 points. So this is a conceptualization of this, and this is what I think about when I think about a risk landscape, but it's only sort of my own mental model. But again, it's the idea that you're in one place at the moment. You want to be somewhere else in the future. You want to be here on the map. But to get between A and B, you've got to navigate this really complex, wickedly complex landscape that has got things in such as health, environment, but it's also got things like public opinion in it, politics, policy, mission objectives, science, and what people think is the right science versus the wrong science, or how to do science or how not to do science. The reason I put this up is if you begin to look at a wicked problem like planetary protection, you've got to work out what the nature of this landscape is and what the tools are to help navigate through it and actually learn how to fill in that landscape as you go. This is not just about protecting the environment or protecting human health or protecting the integrity of science. It's working out what is important to different groups and how you can actually navigate around that to get to a set of common goals. So with that, I actually want to turn back to you and see whether I can get you doing a little bit of work here. Now I've given you the Risk Innovation Primer. And we're going to go through a series of questions here where I want to get a sense from you of how you think about what's important to different groups of people. And I'm going to start with a test question just so we get get a sense of how this is going to work. So this is not an important question, but at least it tells me whether you're on the same page as me. So give this a second to kick in. This always really worries me. Every time this comes up, I think, has the system crashed? Here we go. No. So type one word that you think captures what's most important to kids when it comes to space exploration. And I put one or two sort of seed words up there, but put your own words up. And I think you've already worked this out, but if you see a word on the screen that you like, you can always duplicate it. Okay, great. So adventure, aliens, rockets, Buzz Lightyear, dinosaurs, astronauts, possibility, curiosity. I love this one, actually. I think I might keep this one. Shiny, books, hands-on, ethics. Interesting. Some deep kids out there. Okay, let's just give that a second. Aliens and adventure. Or, yeah, I actually love, wow, yeah, I love this, actually. Let's give that a second more. Okay, good. So you get the idea. So we're going to go through a sequence of these. I'm not going to give you the seed answers on the following slides, but in each one, I want you to do the same thing. I want you to give me your one-word response that you think captures what's most important to different groups. The next one is going to be the public. What one word do you think captures what's most important to the public when it comes to space exploration? Money, cost, safe, aliens. So you can begin to see what we're doing here. I'm trying to get you to put yourself in other people's shoes, to understand what's important to them and what, if that is threatened, they're going to fight against. So this is a way of thinking about risk in terms of thinking about what threats people are going to try and resist. Okay, cost, money, aliens, or practicality, discovery. And again, the beauty of this is that I think that if you were to be identified with this and have your name associated with what you put up there, this would be a very different word cloud. I would be surprised if money and cost came up in quite the same prominence as it does here. But this is interesting. USA #1, Klingons. Yeah, of course. Taxes. I'm surprised taxes isn't bigger, actually. Okay, good. But you're getting the idea. And this idea that cost and money are important here is going to be critical, where if you're part of the community that is trying to push space exploration, you need to be cognizant of what members of the public are going to be thinking about in terms of how they weigh the value of that to them. Okay, next one. Politicians. Type one word that you think captures what's most important to politicians when it comes to space exploration. Cost and resources, mining, money. Is money going to be the answer to everything here? I hope not. Pork, yes. Taxes, nationalism, yep. Economics, success, election, yeah. Re-election, yeah, I'm glad re-election is big. Money has gone red. Votes, yep. So again, you begin to get the idea that if you're in the science community and you're trying to push not only for certain approaches to space exploration, but the inclusion of thinking about planetary protection here, and you're talking to politicians, they're going to be listening to you and they're going to be thinking re-election, votes, money, cost. And if you seem to be threatening any of those, they're going to create barriers for you to achieve what you're trying to achieve. So again, it's important to understand what's important to them, what is at risk to them. Okay, next one. The space industry. So here I'm thinking about the commercial space industry. You can interpret this very largely, but obviously you've got things like SpaceX, Blue Origins, and the rest of them. Okay, profit, money, maybe not surprisingly. Opportunity, prestige, jobs, contracts, publicity, reputation. The reputation one actually is an interesting one because, of course, these commercial companies are out there for profit. But if their reputation, if their brand is damaged, immediately their ability to create that profit disappears. So you can begin to see these associations between things. Discovery is there, good. Penis size, am I allowed to say that? Yes. It had to come up with space exploration and rockets. Dominance, yeah. Okay, great. Moving on. Okay, now, Space engineers. So now we're getting closer to this community here. Fame, oh wow. Fame, success, risk, challenges, technology, yep. So again, this is interesting to me. Somebody's worked out how to put the emojis up. I'm impressed. In fact, I assumed the rocket was actually part of something else. Okay, so maybe this is just a replacement for a phrase on the other slide. So this is all about innovation. I'm so glad to see we've got an innovative cloud here. But you can begin to understand. So when we come to the Q&A session and the comment session, would the person that please put the poop emoji up come and explain exactly what the relevance is? Okay, great. So now we know what's really important to space engineers, which is subverting the system and hacking it and having a bit of fun. Great. Okay, how about NASA? Of course, this is the this is the downside of it being anonymous. Well, maybe not the downside. Funding, success, discovery. Great. And as you can see, again, going through these, different groups, different organizations have got not only different priorities, but different things that are important enough to them that if they're threatened, they will see that as a risk and a risk to be managed and avoided. Yep. Lots of planet, lots of money. Funding and discovery still front and center. Good. I'm glad somebody has actually got NASA's mission. Yes. Space invaders and aliens. Mission, yep. Missions, yep. Public opinion. I'm surprised public opinion isn't bigger, actually, because NASA as an agency depends so critically on public support. Good. Okay. 2 more of these to go. So, scientists. And slowly in your mind, you should be picking up a picture of where the commonalities are between these different groups and where the points of departure are. Because, of course, where there are points of commonality, not only are there common goals, but there are common ways of actually working together towards those goals. Okay, again, knowledge, discovery. Discovery is one that actually comes up quite frequently here, not surprisingly. Knowledge, grants, wonder, dubious. I was just about to say quite a lot of this looks like sort of what are kids excited about, or what's important to kids. Not surprisingly. Facts, grants, learning, dangerous, dangerous. Great. Okay, and the final one, bringing it home. What one word do you think captures what's most important to astrobiologists when it comes to space exploration? Life, aliens, fame again. Okay, hands up who wants fame? No. Validation. Give that a second. Okay, this is great. So what is interesting here? Now you have a divergence. Because this, I'm assuming, represents a large part of the people that are in this room, what's important to you. Life is front and center there. That didn't really come up in any of the other groups. Now, that doesn't mean that life is not important to the other groups, because I'm getting you to try and put yourself in their shoes. And you may get things right, you may not. But clearly, there is this disconnect here in terms of what is really important and where the risk might lie in terms of what is threatened. And just that self-awareness is really helpful in trying to understand how to approach a complex issue like planetary protection and work out what your role is here, what's important to you to protect, and how you can build up alliances with other groups based on what's important to them, and how you can avoid getting yourself in a real mess because you don't realize what's important to them. Okay, life and aliens still there. Cool, I like the cool. Okay, notoriety, great. And we can probably, I'll actually have to check with Steve, we can actually probably send shots of these word clouds around if people are interested afterwards. I actually think they tell us quite a lot. I'll check them first. Okay, so that's good. So we've been through a process where I've given you a bit of an idea of how to think differently about risk, think about planetary protection in terms of a wicked problem, a wicked challenge that is really hard to get our teeth into. And it involves many different stakeholders, many different constituencies, all of them with different priorities, different things that are so important to them that if they're threatened, they would consider that a threat to be eliminated or managed. What I want to do now is work out how you move from those broad, mushy concepts to understanding how we can make sense of that within this particular community. So we're going to open this up to discussion and comment. We've got actually a decent amount of time here. There are some house rules here, and I'm going to have a couple of seed questions to kick things off here. The house rules are stick to the question when there's a question up on the screen. Be brief and constructive. Please do not hog the microphone. Do not be one of these people that feels you have to deliver your thesis at the microphone, because I'm sure there are going to be other people that want to say something. But I want this to be a positive, forward-looking discussion about how this community can move forward with planetary protection, given all of the different ideas and concerns and problems and opportunities, not to solve problems, because we cannot and will not solve problems here. And in fact, you cannot solve problems like this just by groupthink. You actually have to have expertise in the mix. But we can have a conversation around what is important, what are common goals, and how do we actually move together to achieve these goals rather than completely stymieing ourselves. So let me just start with the first question. And as this is coming up, there are microphones in the aisle. So if you do have something to say, so there's comments, questions to the audience, answers to questions, please come up to the mic and introduce yourself before you launch into what is hopefully not your thesis statement. Okay, so just to kick things off, what's your biggest fear if we don't manage forward contamination effectively? And maybe not surprisingly, compromised science. So I'm going to leave that out for a bit and ask you to actually come up to the microphone and just begin talking about where your fears are here, why you had those fears, what you think the nature of the problem or the challenge is here. And it's always difficult getting the first person to come up and speak. This is where, as a lecturer, I'm so tempted to sort of point and say, you, but I won't. So we have microphones here, oh, here. And yes, thank you. So if you just let us know who you are, so at least I know who you are.
Helen Hansma. Don't you think climate change is an incredibly larger risk now on Earth rather than the remote problem of contamination at this moment in time and space?
So I'm not going to give you an answer because I'm not the oracle on this. But so thank you for the question. I would love for other people to respond to that. Interesting that I can't remember seeing climate change coming up as prominently here. But what is so important about the question is that it raises the issue that different people have different priorities. And very clearly, climate change and society on Earth, not only society on Earth, but how we actually deal with disparities between different sections of society is clearly a critical issue and a critical risk. So then how do you balance something that is clearly so critical with something we're doing off Earth? How do you make those trade-offs between where we focus our attention and how we make decisions? I would love for people's thoughts on that, but in the meantime.
Do you want my thought on that, or do you want what I was going to say?
Well, so actually both will do, but I should let you say what you want to say.
Okay, I think that we learn a lot about climate change on Earth by exploring other planets, is my short response to that. Right. It's not one or the other. I think science is integrated in a way that you can address a lot of questions at the same time. What I wanted to say about forward contamination being this big issue for astrobiologists is that a lot of the public desire for space exploration is to send humans. And if we send humans anywhere, we will contaminate the planet because we are dead if we're sterile. And so there's a huge conflict between trying to understand microbial life anywhere and human exploration in particular.
Yeah, thank you. And I'd love to get comments on that as well. So certainly from my perspective, that is a really big value disconnect. I talk about risk. You've got the people that are really dedicated to getting humans on other bodies, see people that don't like that idea because of contamination as a risk to their mission. On the other hand, if your interest is in alien life, or the evolution of life or life-like systems in other systems, the idea of putting humans onto another body is a risk to what you think is incredibly important. So how do we begin to find the common ground between those?
Yeah, I don't think that there's a conflict between sending humans and understanding life before you send humans. And the issue, of course, has to do with whether or not the humans are going into a minefield of another biosphere, or whether or not there's actually the potential for humans to benefit from the lack of life. But if you're going to look for something like a Mars aquifer, it would be tragic to find that there was one there, but some Earth microbe turned it into some kind of a mineral, and you lose that. So I think both are possible, but especially if you want to get into terraforming, I mean, you're going to start making the planet change a lot, but you don't want to be stopped by the microbes you took with you inadvertently.
Right, right.
But it should be a choice.
Right. Of course, one of the challenges here is we're really speculating out into the future, and we see this with risk in so many different areas where we're at the cutting edge. How do you make decisions on things that you don't know whether they're going to happen or not? One thing we do know is the last thing you can do is do nothing because you're scared of the future. So then the question is, how do you make those informed decisions? But also something we might want to come back to in the conversation, because this is a conversation that we're having around cutting-edge emerging technologies, is how do you build resilience into your systems? So when something goes wrong, and I can guarantee if you're actually moving forward, something will go wrong. When something goes wrong, how do you have enough resilience in the system so you can respond to that rapidly and change course rapidly? Yes, if you can say who you are, please.
I'm Linda Billings. I'm a social scientist working in the astrobiology community. And when I look at compromised science as the biggest fear, I can understand that. But as a social scientist, I would think that if NASA were to spend $5 billion on a life detection mission to Mars, and over the course of analysis of the data, it's discovered that the life we've discovered on Mars is actually Earth life, then loss of public trust would really shoot up.
Yeah. Thank you. The next.
I think that climate change is a reason why we should be more cautious about planetary protection, because when you look at anthropogenic climate change and human-based problems, that's a reason why we need to be more careful with when we're exploring other planets, and how colonization historically, even from country to country, has backfired in our faces. Even on this land, Native Americans were oftentimes murdered from diseases and that kind of thing, which is a reason why we should be careful and rethink our ethics.
And certainly, to me, that's a very strong narrative. And I can't think of any one good example where colonization has been uniformly good. As a species, it's been a history of bad ideas, bad mistakes that somehow we've managed to bumble through and actually make some sort of progress for some people afterwards. Yeah, so we don't have a great track record here.
Margaret Race from SETI Institute, and I work on planetary protection. I agree with everything that's been said so far, and I think one of the difficulties I see in dealing with different audiences, different balance questions, is the problem of time. We in the astrobiology community go from years to decades, decades to centuries, no problem, and then centuries to millennia, and then big time. And when we talk about things, we're constantly mixing them up, and when we're talking about trying to solve a problem for forward contamination or make a right policy, somehow time gets left out of it, and we're so comfortable with dealing with this full range of time that we often don't even stop and think about what we mean ourselves.
Great, thank you, yeah. I would like to actually come back to that issue of time and timescales and decision-making processes. Yeah.
My name's Keith.
Oh, sorry, thank you. Yeah, just 2 seconds, thank you.
Right, thank you. I guess the whole question about forward contamination for me boils down to the question of compromising science in the context of actually identifying whether life does exist elsewhere, whether it is a second genesis, and so on. And the big problem in my mind is that it's likely that if life does exist elsewhere, it may well be existent in niches rather than widespread on the surface where, for example, humans might first go. So if we, for example, if Curiosity at Mars and Mars 2020 and so on shows that Mars is sterile on the surface, it does not mean that it is sterile on the subsurface, deep subsurface. So we have to be very cautious about exploration of such bodies and forward contamination, which could in fact prejudice downstream science very far in the future where we go deep and look for other life in other niches.
Great,
So,
thank
anyway.
you. So just another C question before I get to this gentleman. And I'm playing devil's advocate here because I don't believe in this argument myself. But how do you deal with the people that argue that this is very self-indulgent of scientists saying, you've got to leave space to us because we're the only people that know how to work here and not make a mess of it. So if you want to mine asteroids, if you want to colonize Mars, whatever, you should keep your hands off because us scientists have the first choice here and we're the people that know how to do this. So I'm channeling conversations that I've heard. As I said, I don't believe this. But how do you counter arguments like that? Just a seed for further questions. Yes.
My name is Keith Cowing. I'm editor of NASAWatch.com. I'm here covering this meeting. So I also run astrobiology.com, and I'm sitting here a little perplexed because with my phone here, I can tweet to 400,000 people about this, including @astrobiology. And I know the UK tabloids are waiting to see what I tweet so they can write about face-eating Martians. You can go to any other audience and get A's and B's going up and down here. I would just offer that if you feel your audience isn't understanding you, you have the wrong communicators. And if parents can tell kids, wash your hands before dinner, put the lid back on this thing, I mean, basic aspects of microbiology are not that difficult to grasp. So again, if whatever audience you're worried about today is not getting your message, you need new messengers. And maybe that should be, I was at one of the original meetings with Linda and some of the others back in the 1996, 1997. We had a whole group about the whole notion of just explaining this to people.
Yep.
And I, quite frankly, don't see enough of that these days. And you guys may know the topic, but you may not be, you didn't take that class in college about talking to the public.
So actually, let me just add to that. So one of the many hats I wear is actually as a science communicator, both somebody who teaches and does it. And one of the fundamental principles there is focus on your audience. Not only focus on the audience, but actually have audience-centric communication. So you're absolutely right, and this ties in not only with public trust, but a whole range of other things. We can't sit here and say, we have the answers, if you don't get it, you've got something wrong. We've got to think about how you actually build those bridges.
And there is no one single message.
Thank you, yes. Great. I'm going to go over here and then back here.
Hi, name's Andrew Sugar, the University of Florida, and as a preamble, I work in the field of planetary protection, so I've received funds in the past and expect and hope to receive funds in the future, just to be full disclosure here. The concept I want to convey is the term contamination, because contamination, you can have contamination and you can have contamination. I mean, there's a scale there, and it's not one bacterium that is dispersed under the terrain that I'm most worried about. It would be contamination that is able to establish itself, be dispersed around the planet, and move well beyond the immediate landing site or the immediate wheel track of a rover that I think is the issue. So we could transfer small numbers of viable bacteria onto the surface, and that wheel track, for example, is the only thing that gets contaminated, as an example. So there's small contamination, big contamination. And the second concept is that the surface of Mars has a very wide range of biocidal conditions, biocidal factors. 15 to 20 have been published through numbers of papers. What really is the concern is if we have communities or assemblages from Earth transported to Mars, they're able to survive those collection of 20 biocidal conditions, be dispersed into niches that then become established. I just wanted to emphasize this: small contamination, big contamination.
Yeah, no, I really appreciate that. And of course, as part of that, the reason I set it up this way is contamination is a different type of problem from compromised science, because contamination usually comes to how is that presence of Earth-based biological stuff going to compromise my mission, which may be nothing to do with finding alien life. Whereas compromised science is all about how do you prevent something getting into the experiment, which is going to completely nullify the experiment. The other thing actually which struck me from those comments is in the world of psychology and decision analysis and how people actually make sense of information, one of the tools we use is the idea of mental maps, the idea of understanding how people actually process information and make sense of the world. And this applies very, very well to looking at contamination somewhere like Mars or somewhere like another body, where if you're not deeply steeped in the science, it's easy to jump to conclusions that misrepresent the science, and where you can even go as far as assuming that life is likely to propagate on another body in the same way as it would propagate in different ecosystems on Earth. And one of the critical things to do here is make sure we have ways of both understanding where there are misconceptions in people's mental models and understanding how to use the science to reveal how things are actually likely to work rather than how people think things are going to work. And that's a critical leap. It actually comes back to communication, because we need to help people understand the reality of science off Earth, and we need to work out where people's misconceptions are here. We're going to go here, then we're going to go over.
Hi, Stuart Bartlett here. I appreciate this last point because it's intuitively, when you think about it, it seems quite unlikely that microorganisms from Earth, given the extreme nature of exoplanet environments, it seems generically unlikely that they would be able to grow exponentially in an exoplanetary environment. However, backward contamination intuitively seems like it could be more of a risk if we start mining asteroids, for example, and there's some super extremophile that somehow managed to make a living there, and that gets back to Earth, and suddenly it has a real easy time making a living in the less extreme conditions on Earth. That seems intuitively more natural a candidate for spreading exponentially and sort of invading. So I guess backward contamination could become a concern in the future as well.
And perfect segue, because I'm going to go on to the next question, which is about backward contamination. But just before I leave this slide, remember this, because the compromised science reflects this community, and it's important to realize there's actually quite a lot of consensus here about what is important here, but it's also important to realize that there is some diversity and perspective here within this room as well. And it's always relevant to understand the value and the validity of that diversity of opinion. Okay, so while we keep on taking these, let's get on to, or segue into backward contamination. Sir.
Paul Mooney. We're all descendant of contamination.
Yes, yes.
And as far as colonization of space,
Yes.
America, we left a plaque on the moon with Apollo 11. We come in peace for all mankind. And that should stand as a marker for the future.
Right, right. So the one thing I would say, thank you for your point, which is really important. But there's obviously a difference between saying we come in peace and actually not leaving a dirty, great footprint, which we can't erase afterwards.
Hello, my name is Vladimir Arpetian, NASA Goddard Space Flight Center, and I want to comment on not just contamination, but on evolution of contamination. The point is that if we bring a bacteria from other world to Earth, because we have deep biosphere, a biosphere means that biological equilibrium, so the all biological niches are taken, they're going to kill this bacteria. So I don't understand the contamination in that sense. Imagine that we have a biosphere on Mars, subsurface biosphere. We bring a bacteria, and it's just a matter of time. Might be day, might be a month, but if life prospers on Mars, they will kill bacteria on Earth. So I don't understand contamination.
So I'd actually like people to dig into that a little bit more, because this is where I can see tremendous uncertainty, especially from those that are deeply familiar with the biology of especially extremophiles, but also the nature of either modified DNA or non-DNA based life. Because it seems like there's a huge divergence of opinion as to whether alien life would actually be able to survive on Earth because you don't have those niches, or whether it would dominate like an invasive species because it has advantages that others don't have. I don't really get a sense of where there is good science consensus here, but prove me wrong. Let's get a...
I just want to point out that people didn't realize that kudzu would take over the entire South. People didn't realize that honeysuckle would take over the North. People didn't realize that all the diseases that were brought by the original colonizers European colonizers of North America would bring diseases that would kill the native people here. It's sort of, I don't like this argument that, well, we think that the niches are taken up, or we think that the environment is too sterile on Mars, things can't grow there. I think that we need to understand that sometimes scientists don't know things, and when we don't know, we need to be careful because we could really ruin something.
Yeah.
And we've done it before, and we might do it again.
So can I put you on the spot and keep you on? I just want to sort of ask a follow-on question to that. So and again, you look through the history of humanity, and that has been our legacy, that we do things out of ignorance, even though we think we're pretty smart at the time, and we spend the next sort of years, decades, centuries, millennia sometimes, mopping up the mess afterwards. But we have done things, and some would say we've actually progressed as a society, probably because of our mistakes. So how do we then find that line between not doing anything because we know that we're going to mess up, or doing something because that's the human imperative anyway?
And I think that's a question of our goal. So if we're going to Mars looking for Martian life, if we're looking for a second genesis of life, then we have to be very careful that we don't bring any of our own species there, even if we think there's no chance of them surviving. However, if our goal is to terraform Mars, make it more like Earth, and make it so that we can live there, then I think we need to basically assume that we're going to be bringing our organisms there. We're going to make that like Earth. And then that's our goal. We need to know what our goal is. I think that's the most important part about it.
Thank you, which I think is really important here, and also knowing what other people's goals are and how you can actually find that point of convergence. Yes?
Mike Travisano, University of Minnesota. So following up on that last one, so there's been a lot of efforts to investigate what the properties are of invasive species here on Earth, moving them around. And by and large, we have no general consensus. So the ecologists and evolutionary biologists are really challenged by it. What you typically see is for things that have their own primary productivity to make energy from the sun, is that they don't get eaten. So they escape, and they're quite happy to not be eaten. And the things that eat things don't have it, just go berserk and eat everything. So those are the properties of the contamination that have frequently been problematic.
Great, thank you. So this is going to be the last question because I have one final slide and we need to wrap up, but please.
Lucas Mix from Harvard. I would say both from a risk perspective and from a science perspective, one of the things we try and do is avoid confounding variables. So to my mind, one of the benefits of planetary protection is that we save the Mars questions for Mars and the Earth science questions for Earth, because we know when the two will interact, it will be a less predictable system than it currently is.
Great, okay, thank you. That's a nice place to finish. So just before I leave this slide, again, I think this is important just for getting the feel of where opinion is here. It's not necessarily the ultimate opinion or representing different groups, but the fact that environmental impact is clearly important here, followed by human health impact, but also loss of public, that should say loss of public trust, not loss of public, which would be disastrous. But the fact that it's there is important. But I also think it's important to understand why loss of public trust is relevant here. And it's a complex question, but it's partly down to the legitimacy of what different organizations, what different groups, what different individuals do here, because ultimately everything needs to come down to the legitimacy that society places on it. But also it's down to the fact that we're all part of this society that has a stake in what we do in this solar system and beyond. So whether you agree with people or don't, or whether people understand the science or don't, or whether they understand the politics or the policy or the broader conditions and situations, everybody has got some stake, some voice in this. And so it's really important that we actually engage with different members and sectors of the public, different institutions and organizations, if progress is going to be made. So I just want to wrap up, but I want to wrap up by going back to this question that I asked you earlier again, because I'm intrigued to see whether there's any difference. So final question, again, what comes to mind when you think of planetary protection? I'll give you a second to respond to that. Glass of wine, spot on. So the big thing as I go back through these that will be different is that we've learned how to use emojis at this point, and we didn't know that before. So as you're doing that, I just want to wrap up by saying, first of all, thank you for indulging me. It's not always easy when you have somebody that isn't a deep expert in an area come to talk. But I hope that this has actually stimulated some of your thinking and especially stimulated conversations, not about people balkanizing themselves into their technical areas of expertise when it comes to planetary protection, but having broader conversations about what is important here to you, what is important to others, and how, as communities and as a society, we can actually move forward so we actually do think seriously about the issues around planetary protection, at the same time not stymieing what we think is important in terms of space exploration. Thank you very much.